Good morning. I'm Zhongsheng Liao from National Zhongzheng University Law School. 我是廖宗胜，现在任职于中正大学的法律系。I'm so glad to be here and to be the section chair in this forum. Just a little bit information about me. I have working on three big areas. First, climate change, and second, human rights, and third, renewable energy, and try to figure out how to link to each other. And as a law, okay, as a law person, so I'm working on the policies and regulations and also strategies. Okay, and today we are so glad to have a very, very distinguished professor, or I should say experts, Professor Zeisinger with us. And he is from Canada, but also from the US. And let me check this. Okay, let me introduce her to everyone. He is the professor at the School of Environmental Studies at University Victoria in Canada. And then he is also a member of steering committee of UN Global Climate Observing System. And in the past, he was the executive director of Pacific Institute for Climate Solution, also at University Victoria. And then he was also the executive director at the International Geosphere Biosphere Program. And he has earned a lot of awards and honors. And because we don't have time to say the whole list, just name a few. He received AC Redfield Lifetime Achievement Award from American Geophysical Union in 2020. And she also was an elected fellow of American Academy of Arts and Science in 2011. So we got so happy to have Professor Zeisinger with us. And so let's just give warm welcome to Professor Zeisinger, and he will give us a speech about taking actions on climate change, mitigation and adaptation in Canada and British Columbia. Okay, Professor Zeisinger, please.
Thank you. And it's a great honor to be here and to be back actually in Taiwan. And thank you very much for inviting me to be here and to spend some time learning more about what's happening here in Taiwan with climate action. So this is my second time in Taiwan. I was here about 10 years ago with an international delegation representing a large global environmental change research program. And our scientific committee met here in Kaohsiung. And also many Taiwanese scientists were involved in that program. So it's great to be back, and I have great memories of Taiwan. And so it's wonderful to be here. What brings me to Taiwan this time is that I'm on sabbatical, so a one-year study leave from the university, and I'm traveling around the world looking at in various countries at what's happening with climate change impacts and what the plans are for both decreasing emissions and for adapting to the impacts of those climate change, both currently as well as preparing for the future. So this is one of the stops on my journey, and we're here and we'll be gone for almost 7 months from home as we travel around the world. So it's very exciting to be here. And I look forward to the next 2 weeks of learning a lot more about what's happening here in Taiwan. So on with the presentation. This is going to be a very broad overview of what's happening with mitigation and adaptation to climate change in Canada and in British Columbia, mainly British Columbia because that's where I'm located and that's where the Pacific Institute for Climate Solutions is located. And I'll say a little bit more about that in a few minutes. But as we are all very aware, climate change has been impacting everywhere around the world. Already we have heat waves, we have droughts, There are insect infestations, flooding, sea level rise. And one of the challenges that we also have in Canada is melting of permafrost, which is disrupting our roads, our infrastructure in many different ways. Probably more than anybody ever expected, we're already seeing around the world impacts of climate change. And of course, the international agreements such as the Paris Agreement in 2015 and subsequent updates to that from the COPs, the Conference of the Party meetings, are very important in providing a framework for action. But it's really at the national level and the subnational level that the plans and actions need to be happening to actually support those international agreements and move forward with really decreasing the current and future impacts of climate change. In Canada, we have a 2030 emissions reduction plan for greenhouse gas emission reductions, and now we also have an adaptation plan. And in British Columbia, we also have a greenhouse gas emission reduction plan called Clean BC, which I'll talk a little bit more about later, and also an adaptation plan. But I think that in Canada, we're becoming more and more aware of climate change. Even as of 10 years ago, there were areas in Canada, you can't quite see, but basically that's the outline of Canada. And you can see that there are areas that already as of 10 years ago had a 3-degree increase in temperature, annual temperatures. So that's as of 10 years ago, and it's increased even further since then. So we're already seeing major impacts. But I think in British Columbia, which is the westernmost province, which is the one that's in the darker color on the far left on the Pacific coast, we really kind of thought, I think, even as of 7 years ago, that we were kind of immune to climate change in terms of we weren't going to be affected very much. We're far north. Our temperatures are cold, and we have a very sparse population. And we really thought that we weren't going to have many impacts of climate change. And we're a fairly wealthy province as well. But time has shown us to be very different than that. Let me say a few more words about British Columbia. In terms of the size of the area of British Columbia, it's 4 times the size of Taiwan. In terms of population, we're 3 times the size of Taiwan. And in terms of population, we have about 4 times less people living in British Columbia than you do here in Taiwan. So you can see we're very low population, very large province. Also, we have a few cities, Vancouver in the lower, sorry, if I could get up. See here, yep. Vancouver in the lower left-hand corner there, and Victoria are our major cities. But really most of the province has quite small communities, and many of them aren't even connected by roads. So we depend a lot on air traffic to move people around. And we have a beautiful coastline as well. We're also a province that's basically mountainous. Quite high mountains, in fact, rugged mountains. So that also makes things quite disconnected in many ways, except along the coast. And the green indicates that it's actually almost entirely forested. And that's a very important part of our economy. We depend on logging of those forests and sell basically raw logs, unprocessed, to the US and to Asia for construction. So that gives you a little bit of an idea of the province. It's also very beautiful. We have a gorgeous coastline with very clean water, lots of wildlife. That bear is not unusual. If you go camping or hiking, you better be ready to encounter a bear. Also lots of whales and salmon migrating thousands of kilometers upstream, beautiful hiking areas, a really gorgeous province. We're very blessed with that. But we also have industry. We have a major port in Vancouver. We have mining in especially the northern part of the province, and also natural gas extraction in the northern part of the province, and a lot of train traffic that is also moving goods and services around the province. That's Victoria on the left, which is where I live. It's the capital of the province. And also we have some agriculture, mainly fruits, vegetables, and vineyards. And again, like I said, logging. And I want to point out here the Victoria, we were very honored for 2 summers to have Professor Lau visit us at the Pacific Institute for Climate Solutions in Victoria. So he knows that area well. But as I said, in British Columbia, we sort of thought we were not going to be heavily impacted by climate change, but that has really not been the case. In 2021 and 2022, we've had real big, massive heat waves, extreme heat, and more people lost their lives in those summers because of the heat than in any other natural disaster in Canada in history. So it's really surprising us there, and we really need to adapt to that and plan for those extreme temperatures, particularly in our urban areas, but also in the agricultural fields and workers out in the farms. We've had massive floods, for example, in the fall of 2021. We had what's called an atmospheric river, or it's also called the Pineapple Express, which is where lots of water vapor is traveling from basically the tropical Pacific and deposits massive amounts of water in rain in heavy downpours, short periods of time on the landscape. Roads were washed out, bridges were washed out. Basically, the east-west traffic through the province was stopped for many weeks. We had disruptions of food, of supplies for gasoline. It was truly a disaster, and also extremely expensive to repair those. And then in many years now, and starting in especially 2017, we've had extensive wildfires. Those wildfires are a result of not only the increase in temperatures, and also the droughts that we're having, but also we've had extensive loss of pine trees from a pine bark beetle. And that pine beetle is normally there, but because we have warmer winters now, the population of the insects does not decrease during the winter so much. And so they then explode when it comes into the summer, and thousands of acres or hectares of forests have been decimated, and leaves then dead trees standing, which is great fuel for wildfires as well. So we have many impacts already, and we know that those are not going to be stable, but probably increase with time. So where are we? In terms of our greenhouse gas emissions, our major source of emissions is actually transport. That may be somewhat surprising, but because that's not the case in many areas. We're very fortunate in that we have basically clean electricity. We have hydropower. And so you can see that the greenhouse gas emissions for the province, only 1% comes from electricity generation, but that's because of the hydropower from the dams. But still, 3/4 of our energy is from fossil fuel, and road transport is a major source of that. Then we have about 22% from industrial sources, primarily the fossil fuel industry and also mining. And then our buildings, our infrastructure also, and then a number of other smaller sources. There we go. In terms of transport, it's one of those areas that many places around the world are starting to act on, including in British Columbia. About 1/3 of that emissions from transport are from cars. Basically, we call it light duty transport. About 1/3 from heavy duty trucking. Large trucks supplying the province with all the things that we need, and about another 1/3 from off-road, including our air travel within the province, railroads, and large equipment for the mining industry. In terms of the light duty, which in other words, the cars, we have a directive now that by 2035, 100% of all new cars have to be zero emission vehicles. So basically electric. We're not really going towards hydrogen in terms of cars, but really electric. And so that's actually being phased in. And right now we have a really quite rapid uptake of electric vehicles, electric cars. In fact, we're exceeding our targets right now. In terms of heavy duty trucking, that's a bigger challenge because as we know, batteries are not really a good solution for these big trucks that have really heavy payloads. And so we're looking into biofuels as well as hydrogen. And doing some testing of that. But we're starting to develop targets now also for heavy duty trucking. And our off-road is a challenge, of course, as it is everywhere in terms of air flights. One of our local air plane companies, not hydro, but I'm phasing out here on the word, but basically small planes that fly between the islands and along the coast and also inland. And so they've, in 2019, they had the first test of a commercial plane that was all electric. And this year they plan to actually put that into regular operation. It only is small flights. They don't go over the water. It's too dangerous still, but they're really trying to move forward with moving some of our off-road transport also. Then there's also, of course, the industrial and the buildings and the other sectors as well, which need to be worked on. But basically 3/4 of our emissions come from fossil fuel combustion. And so really the plan in the province is to essentially electrify everything. And while we have all of our current electricity is clean, we're going to need to greatly increase our electricity production from clean renewable sources in order to support the transition of all of our transport, our mining, our industry, and our buildings to a clean energy source. And that's going to be a big challenge. I'm going to just speak a little bit more before I talk about how our plans are for moving forward with where we are with our emissions. As you can see, we haven't done very well in terms of decreasing them. So starting in 2008, we did put into place a carbon tax and a emission reduction plan. That carbon tax, well, you see that there was a small decrease in our emissions following the introduction of that carbon tax, but no further decrease really. And it's very questionable to the extent that that carbon tax was actually responsible for that small decrease. So we have many regulations, but those regulations under that existing governments up until about 2018 was not really very attentive to implementing the plans that were in place and really regulating that. We now have a much more aggressive government in terms of climate change in British Columbia and in Canada overall. And our emissions still have been increasing, as you can see, up until about 2020, primarily from the natural gas extraction industry. But we now have a very strong plan in place with very specific targets for each of the different sectors and very specific plans for how to have those emission reductions take place. Our target is by 2030, which is barely 7 years away, to have a 40% reduction in emissions. The blue and the green are just two different plans, a first stage plan and a second stage plan for getting us to a 40% reduction. But we're also committed to getting to net zero by 2050. Those plans are still not developed. And just to give you a little bit of insight, I know you can't read this, but basically our newest plan for reducing emissions is called the Roadmap to 2030. And each of the sectors have very specific emission reduction targets. So it's not just an overall 40% emission reduction, but very specific targets for each of the sectors that need to have those reductions happen, and also timelines on them. We've also instituted a very good accounting each year for transparency and also what the emissions are each year in each of these sectors, whether they're on target or whether they're on track or whether they're not. And if they're not on track, what's going to be done to get them back on track for the emission reductions. So much more accountability than there ever has been in the past, and much more transparency, which we hope will result in large reductions. But how are we going to get from our 70% use of fossil fuel for energy in the province to basically 100% of clean energy use? We've got to decrease our road transport, our industry, our buildings, essentially all sectors of society. As I mentioned, 30% of our energy use right now is electricity, and it's clean from hydropower, but we don't have much capacity for increasing our hydropower electricity. We basically dammed all the rivers. We're using some small run-of-river electricity generation, but that's quite limited. So how do we move now to having 90% or more clean energy? And we're looking at, of course, the normal ones that everybody's looking at: biofuel, wind and solar. We have some big challenges there. We don't have a lot of extra land for growing crops for making biofuel. We're importing right now crops for biofuel production in the province. Our wind is also, we're developing onshore and offshore wind, and solar. We're quite far north, so solar isn't necessarily an excellent solution, but we do have some solar farms being developed. But one of the things that we're looking at is better grid integration of our transmission system, electrical transmission system, with our neighboring province. Our neighboring province is Alberta, and Alberta has a lot of potential for wind. It's very windy, very flat, and also for solar. So can we now develop better relationships with Alberta? There's a lot of back and forth with Alberta on numerous things, but basically increase the grid integration so that, for example, when it's windy or they have an excess electricity from wind or from solar, they could sell that electricity to British Columbia. We could then give them electricity from our excess hydro. And then when the wind isn't blowing, when the wind isn't blowing or they don't have enough solar, we could sell them electricity from our hydro. So basically switching back and forth. We do that already with California and with Oregon and Washington. There's a lot of trading of energy back and forth already, but we have to rely more on using electricity from outside of the province. So how do we now move into solutions? We can always look at the problems. We can dream about solutions, but how are we actually going to develop solutions that are effective and are durable? One of the ways is, of course, that we need to not just have the scientific community involved, but we need to have every aspect of the economy involved. We need to have business and finance involved. Of course, we need to have government involved. We need to have building codes from municipalities involved for infrastructure. We need to understand the risks. So we really need to bring together the whole ecosystem of the province to help develop solutions. And that's one of the reasons that the Pacific Institute for Climate Solutions was formed in 2008 with a major endowment from the government. We're independent, totally independent from the government, but the money did originally come from the government. And the way we operate is in a very co-designed way, a very collaborative way with partnerships. The partnerships really are the foundation of what we do. And we are an institute that cuts across the 4 major research universities in British Columbia, the University of British Columbia, Simon Fraser University, the University of Victoria, and the University of Northern British Columbia. And so the research that we fund involves researchers from all 4 of these universities and beyond, and also many, many different departments, all the way from the business schools to the fine arts to the engineering and beyond. And we do collaborative projects that are in collaboration with what we call solution seekers. And the solution seekers are those that need new information to make better decisions on climate mitigation and adaptation. So we work collaboratively with governments, with business, with First Nations, which are indigenous communities, with non-governmental organizations at all levels, and directly with communities themselves, to really come up with solutions that are usable. And as I said, we do this in a co-designed way, that any project that we fund has to be co-designed between the solution seekers, whether it's government or the private sector or First Nations, and the researchers and the university. So what are the questions that the solution seekers have that they need new knowledge for to be able to develop better solutions within their agencies or within their companies? And what are the talents or the expertise that the researchers and the interests that the researchers have in working with the solution seekers to develop that new knowledge? So they submit proposals to PICS, the Pacific Institute for Climate Solutions, we call it PICS. And then we send those proposals out for international peer review. And that review is done by both academics and it's also done by solution seekers. So we then choose which proposals to fund. And once those proposals are funded, PICS stays involved in each of those projects. We help to organize and facilitate monthly meetings with the research teams, and there are many students involved in these projects as well. We help with communications. We help with helping to develop workshops, seminars, and really a lot of sort of value added to the projects that they don't have the time or the expertise themselves to do, and really keeping the project team together as they work together to develop the new knowledge. And the project needs to go also to actually towards implementation. So we're really looking for the results of the research to be used. That's one of the criteria for every project that we fund. It needs to have usable outcomes, and not just usable, but actually outcomes that are actually used. We've had considerable success with this. It's only been really in operation for about 3 years now. But we're already seeing that results of projects are really being used by government and by the private sector. Okay, now I want to turn in the last few minutes of the talk to some of the projects that we're funding and give examples of how we're doing this co-design, co-development, co-implementation. And as I mentioned earlier, wildfire is a major problem for us. And it certainly has major human health effects. We have days in which you can't even see the sun. Normally we have very clear skies. So we have problems with people with respiratory effects. Those wildfires also, of course, are burning down whole communities, destroying infrastructure, destroying ecosystems. And once an area the trees are all burned down and the vegetation is gone, and then we have a major precipitation event, we have big landslides, which cause problems, of course. So it has many implications. And it also results in trees that are no longer in our economy. They're burned down, or we have standing wood that is charred and not very usable for logs, basically for construction. So big challenges there. The other thing is that these wildfires are, as everybody knows, globally, forests are an important sink for carbon, right? But once these fires go through a forest, that carbon goes back into the atmosphere. And actually in the 2017 and 2018 major wildfire seasons, more carbon was emitted back to the atmosphere than from all the fossil fuel use in the province in each of those years. So 2 to 3 times more carbon was emitted back to the atmosphere than from the fossil fuel use in the province in each of those years. So it's a major source now of carbon back to the atmosphere, and it's not being accounted for very well. And so it needs to come back into the equation. So in this project, We have researchers from the universities, not only in British Columbia, but also collaborations with the US at the University of Washington. We have agencies in the BC government involved and the Canadian government involved, and also scientists from the US Forest Service involved. So this is really a transboundary project. And researchers from the Pacific Institute for Climate Solutions as well. It has, of course, hits the headlines as we're seeing that climate change is really a driving force behind this, that it is a major impacts, not only in terms of communities, but very, very expensive for the province in terms of fighting these wildfires and recovering from them as well. And of course, we know that it's not just in British Columbia and the northwest of the US, but globally, we have wildfires, and those wildfires in many places are increasing. This is from a satellite imagery from NASA showing thermal hotspots in August of this year around parts of the world. It's a little dark, but you can see the bright colors of where in Southern Africa, in much of South America, in the US, and in parts of Asia and Europe, major wildfires, not just from forest, but also from grassland fires as well. So this project is looking at a very interdisciplinary approach, looking at how to maximize the carbon sinks in the forest by minimizing, not stopping the wildfires, but by minimizing the intensity and extent of the wildfires, making them more the intensity that they were more in a natural environment. One of our challenges is that basically we almost have a monoculture of fir trees in the province. And those fir trees, which are coniferous, have needles, have a lot of resin in them, and so they burn very hot and very fast. And so looking to how we can develop more of a mosaic on the landscape with maybe more deciduous trees, hardwoods that have leaves that aren't as flammable, that can actually form some fire breaks. Also, maybe we need to do more thinning of, especially around communities and around other infrastructure. And also how we can better use all the wood that we harvest, not just selling raw logs to the US, but using that to develop higher value products as well, including even some of the wood that is burned and is charred, is how can we use that in various products and increase the value of that for the province's economy. It's just an example of a field trip we took to one of the sites. And you can see that there's basically no trees left in that area. And that really, in some areas that have had really intense wildfires in British Columbia, but also in California and in Washington, that they think that it's going to take years before anything will grow there again because the organic matter in the soil has even been burned, as well as the trees. So the seed banks. Okay, just want to talk about a couple more projects quickly. One is, of course, sea level rise. We are a coastal province, and we are experiencing sea level rise, as are many places around the world. Our major port, Vancouver, is basically almost at sea level, a lot of it because it's at the mouth of the Fraser River Delta. And our major airport is located there. Our major ferry port and major shipping port is basically at sea level. We have very high value infrastructure, real estate along the coast, as well as agricultural area. So we have a very big challenge with climate change, with sea level rise in a number of areas of the province. This project, again, includes researchers from many universities, not just in Canada, but also in the Netherlands, Wageningen University. And of course, Netherlands has a long history of challenge with sea level in that a large part of that country is below sea level. This project also is working with First Nations. So First Nations are our indigenous communities. And in British Columbia, we have 200 different First Nations, each with their own culture, each with their own value systems. And on those 200 First Nations, 30 of them, there are 30 different First Nation languages and over 60 dialects, okay? And very importantly, as a result, in part, of the UN Declaration on the Rights of Indigenous Peoples, Canada and British Columbia have taken very seriously the rights of First Nations. And in British Columbia, there were never basically any treaties that were signed with the First Nations with the European settlers. And so basically in British Columbia, we're living on what we call unceded territory, land that was never officially given to or purchased from or agreed upon to the Europeans when it was settled. And so we're trying to right some of that and work with First Nations, involving them in the decision-making in many, many levels, not only in the province, but throughout Canada. So this project has very important First Nation involvement, as well as multiple municipalities, West Coast Environmental Law, and ministries in the environment. And that's just an example of some of the increase in storm surges that we're experiencing in the province. So this project is really looking at how can we use Indigenous knowledge and Indigenous values along with Western knowledge and values and bring those together to address sea level rise in British Columbia. The really foregrounding the community values and the Indigenous knowledge, not overriding that, looking to broaden the solution space, developing tools and designs that basically use not only sort of, in some cases, still hard infrastructure, seawalls where needed, but also seeing where we can use nature-based solutions to help mitigate the increases in sea level and flooding in these areas. And providing then recommendations to the government and to the First Nations on how we're going to move forward together. It's a very challenging project. It requires a lot of listening. The first year of the project was basically listening and exchanging ideas. And now they're moving more into projects in terms of pilot projects, using living dikes, trying to do some sediment enhancement, also some visualization to sort of dream about what are the possible futures together. And then, of course, the environment's important, but we also need to very much think about the economy and how are we going to transition to a green economy. And another project that we have is working with the BC Investment Management Corporation, which manages basically most of the pension funds in the province. And it's working with the business school at the University of Victoria. How can they move their money and use their money more effectively to secure not only their portfolio, but to support climate change, mitigation and adaptation. So BCI has a portfolio of over $200 billion in their global portfolio. And the researchers are working with BCI to help them to understand the climate scenarios and the projections for the future from the IPCC, from the International Energy Agency, and others, so that the BCI can better understand what the risks are to their various asset classes and their various industries that they have investments in across countries, not just within Canada, but internationally. And how can they use that information then to assess the risk and to assess how they should make management decisions on their investments so that they can better inform their portfolio so that it is more robust, more durable for the future. And of course, continue to make adjustments as climate change moves forward. It's a very complex, again, project, but involves a lot of people working together to understand the perspectives of each other, to interpret information back and forth. And I think it's being very successful and really moving into now some adjustments planned adjustments and challenges there to their portfolio. And finally, I'll wrap up with one other project, which is geosequestration. And basically all the IPCC modeling work in the past reports has shown that we not only need to get to net zero emissions globally, but we need to actually remove CO2 from the atmosphere. We already have too much CO2 in the atmosphere. We're seeing the impacts already. And as we continue to emit CO2 and other greenhouse gases, the concentrations in the atmosphere are going to continue to climb. So until we can get our emissions to zero, and then even beyond that, we need to be removing carbon dioxide actually from the atmosphere to decrease the impacts of climate change as well. So this project is looking at how can we remove CO2 from the atmosphere, from these emission sources and from the historical emissions that are in the atmosphere, and permanently remove it from the atmosphere in a very durable, long-term process. So this project, which is called Solid Carbon, is based on removing carbon dioxide directly from the atmosphere, so pumping air basically through various chemical solutions and through various membranes to concentrate the CO2, and then the energy to support that process coming from wind power and offshore wind, so renewable energy. That CO2 then would be pumped below the seafloor into the basalt at the bottom of the ocean, where it chemically reacts with the basalt to form rock. So it forms solid carbonates. So it's a permanent removal. It's relatively quick. It takes maybe a few years for the CO2 to react with the basalt. The basalt is where it's injected is about almost a kilometer below the bottom of the ocean. So it's not even near the surface of the bottom of the ocean. And so this project is looking at all the engineering aspects. It's looking at the renewable energy aspects. It's looking at the legal aspects, looking at the social impacts, the social acceptance part of it, a very integrated project. And it's hoping to get enough money to move into a demonstration phase. Right now, they're developing the feasibility documents to bring this to fruition. So that is some examples of the projects that PICS has been funding, some examples of how the province is taking action on climate change, and how we're planning to move forward and work not only with our adjacent provinces, but also with other places around the world in developing what we hope will be durable and effective solutions. Thank you.
Hey, thank you very much, Professor Zeisinger, for excellent speech. There are many things, and for me, are very interesting, and then especially how to have a project co-design, co-implemented, and involve so many stakeholders. I think that's very difficult. As Professor Hao, our Vice President, mentioned, that we kind of working on to establish a center called ESG, Innovative Research and Solution Center. Yeah, but it's very hard, to find a right and good people and work together, and then for a long time, not just for a short time. Yeah, so that's, I think our audience may have many questions about that or other parts. So since we have enough time, so maybe may I make a suggestion? We take question, open the floor to the audience and take question for 10 minutes, and then we take a break for 10 or 15 minutes. Because I watched the schedules, we didn't have a break time. I think we need to take a 10 or 15 minutes break, okay? So now we can take questions, maybe 2 or 3, yeah. And if you want to ask questions, please say your name first and maybe your institute which you work for, and then your question. Thank you.
欢迎线上的伙伴能够针对这个问题，刚刚的一个演讲提出您的问题。那我们的议程当中会如亮老师提到的，会加入我们的一个中间的休息的时段。那欢迎线上的伙伴们跟我们提出相关的一些议题。
I saw Candice, right? Yeah, she raised her hand, maybe, yeah. So they just turn on their microphone or something. How could they do?
Hi.
Oh, yeah,
Hi,
please.
sybil. Yes, Professor Lysinker. Nice to see you again. Welcome back to Taiwan. This is Candice Long from Academia Sinica. Thank you very much for your wonderful presentation to introduce your national and from national and then to local really solution. And so my question actually, the first one is related to heat adaptation, because you mentioned that even in British Columbia, temperature increase is really, double of the global mean. So in terms of your projects, whether you have any projects supporting any adaptation plan for this heat, high heat during the summertime. And I wonder whether, you can introduce some research outcome or research framework of this heat adaptation. That's my first question. My second question is actually related to, because you yourself is a geoscientist or ocean scientist background, and I know currently we are emphasizing in social involved social scientists, for example, the economics and the social scientists into this collaboration to make an implementation on the ground. However, I just want to know whether you can see any important role of the geoscientists in the future adaptation or mitigation research. Because currently I see the important role of economics and lawyers or engineering, but for the typical geoscientists working on earth science, atmospheric or ocean science or earth science, do you have any suggestion of the important role we can play in the future adaptation and mitigation research? Thank you very much.
Candice, it's wonderful to see you. I can see you online here, so it's great. Thank you.
Thank you.
Very, very wonderful. Candice and I have known each other for 10 years, let's say.
10 years? Yes.
10 years, maybe
10
more,
years.
maybe more.
Yes.
Candice was very heavily involved in the International Geosphere Biosphere Program, which is now also has moved into Future Earth, and there's a Future Earth hub at Academic Sinica now, so that's great. And so the question, let me get back to the question. Let me start with the second question first, the role of geoscientists. I mean, we absolutely need both geoscientists and social scientists involved in adaptation and mitigation. I think there's a huge role for geoscientists in terms, for example, of understanding these atmospheric rivers that we get that are coming and dumping large amounts of rainfall onto our province. We need to be able to forecast those, we need to be able to prepare for those, and we need emergency response that can work with those modelers to understand what they need to do and when they need to act. Also, I think in geoscientists, very much in our solid carbon project, are really looking at the sequestration, the chemical reactions going on in the basalt with the carbon dioxide. In terms of geoscientists, in terms of engineers, in terms of how do we build bridges, how do we build infrastructure that can withstand the changes in temperature, the changes in wind, the changes in river flows, basically the infrastructure that is being addressed or attacked by climate change. So I think it's really, though, the collaborations between the geoscientists and the social scientists that's really needed. And so they're both equally important. And I think that anybody that's looking to their future careers, the students of today, I think should understand that essentially any area that they go into, whether it's in the arts, the sciences, the social sciences, law, whatever, that their business, that their work is going to need to, they're going to need to know about climate change, and they're going to be needing to help whoever they work with develop ways to decrease the emissions and also to adapt their businesses. So in terms of high heat, so we have funded some projects looking at how to decrease heat islands. Some of the sort of the classical ways of increasing trees in these urban areas, but also looking to see where those trees should be most effectively planted. But also I think the province is really looking much more at emergency response and emergency response to those heat effects, and being proactive in terms of knowing where people who are living in small crowded apartments without air conditioning are living, and being able to go and help them make it through these high heat events, and having central locations that people can go to and basically shelter during the heat events, and areas that are very comfortable for them to be, and designing communities that may be having that also. A part of the community, so that each house doesn't have to necessarily have all the cooling it needs, but can have more centralized areas that people can go to get relief. So that's just some ideas there of what we've been working on.
Thank you very much. Thank you.
Thank you.
Yeah, welcome, and then hope you can visit Taipei very soon.
Yeah.
Okay, great. Thank you, Candice Long. Thank you for your wonderful questions and our answers. And now we can take maybe one more question. Any questions from our audience?
线上的伙伴，如果您需要做一个中文的一个发问也 OK 的，好，欢迎大家能够对于刚刚的一些演讲内容提出一些用中文发问，也可以能够得到回应。
You can also ask in Mandarin, and then we will try to help you to translate into English. So no problem. You can just raise your hand and then ask question in Mandarin. Okay, if nobody want to ask question, I'm gonna use this chance to ask a question. Yeah, as I mentioned, I'm so interested in the project. Yeah, the PICS funded project. But before the PICS fund the project, you need to find the solution seekers, right? And on the other hand, you need to find the researchers. And for me, it's very difficult because you have different university, you have different company, they have different thoughts. And how could you find those solution seekers and also find the researchers? Yeah, that's my question.
So I think one of our advantages is that British Columbia is a small province in terms of the number of people, and that we also have a government and a population that is very attuned to knowing that they've got to act on climate change. And that we, and the other, so that's one aspect. I think another aspect of it is that PICS has a lot of funding, and funding, you know, follow the money, right? And so, so researchers are always looking for funding for their research, right? And so because we have funding and substantial amounts, really, that brings the researchers in as well. And then we rely on the researchers to find the solution seekers. We can help, but basically to begin with, it's been more where researchers, academics already had some existing relationships with business or with government, I think. But now, after a couple of years, and now that this model of operation has become more widely known in the province, now we're having solution seekers coming to us directly and saying, can you help us find the researchers that we should be working with on these issues. And so now we're doing also matchmaking, as you can see. But it takes a while for both the research community and the solution seeker community to become aware of these opportunities and to see also how the results can be beneficial to them from projects that we've funded. For example, one of the projects that we funded was working with British Columbia Housing, the Ministry of Housing, and they're responsible for social housing in the province. And they wanted to be able to change their building codes, basically, to incorporate both mitigation and adaptation into the new buildings. So both how they can design and build buildings that not only have essentially zero emissions, but also where people can live in them even during heat waves, during major storms, so can also be adaptable or be adaptive living quarters. And so they worked with researchers from University of British Columbia, which the student actually involved in that was an architect. And so they worked very closely together. And in the end, a whole new framework was developed. And it's actually, the ministry has now actually implemented in 3 pilot projects and 3 new buildings, actually trialing this new framework. And so they're now putting money into the project, as well as PICS was funding the project. And now other ministries in the government are looking at this framework for using it as well when they're supporting the building of projects. So, but it takes time. As you said, it can't be just a really short-term 1 or 2 years. You know, it really takes time and patience. And not every project is going to be successful, right? But the more people see success, the more they see, maybe my problem could be addressed from the university. So I think it's a process.
Yeah. Thank you very much. Yeah, they did tell me, try to think how to establish the ESG center. Yeah, okay. I think we are on time, right? And then thank you so much. We just finished our this section, and I'm happy to be the section chair. And now I'm wrap up this section, and then maybe take 15 or 几分钟休息. Only 5. It's very short. How about 10? Okay. Okay. Let's take a 10 minutes break, and then I will turn over the floor to the Professor Chen, right? Yeah, later. Okay. Thank you.
OK， 线上伙伴，那谢谢耀老师的一个主持，那也谢谢 sybil 跟我们的一些演讲。那我们休息的时间